Hi, this is Synthchaser from Synthchaser.com. Today we're going to be restoring this ARP Omni 2 for John. John's getting an ARP collection, and I just made a Pro DGX, a matching Pro DGX with the same black and orange color scheme. And we put orange LED sliders in, and we're going to make a matching ARP Omni 2. So this ARP Omni 2 came to me broken. I've never turned it on or opened it up. I forget even specifically what the person said was wrong with this that I bought it from, but we're going to do a full overhaul of it. So we're going to replace the sliders with LED sliders. The sliders are super gummed up. I mean, they're just ridiculously junked up. So we're going to replace them with the smooth LED sliders. I have a kit that we can put in here with LED sliders. These are modern sliders. They're smooth and they light up and look cool. So we're going to do that. We're going to refurbish the keyboard. It's a little noisy, and I'm sure the key contacts are dirty. And let's open this up and have a look inside. I have never seen the inside of this keyboard, so I mean, of this particular keyboard. I've seen the inside of a lot of ARP Omnis, but not this one. So I don't know what we're going to be facing. The sliders, from the sliders, it looks like there's a lot of dirt and dust in there. There's only 2 screws holding this one closed. So I'll remove them, and we'll open it up and have a look. Let's see, hopefully nothing jumps out at me. And we have dangling circuit boards. Alright. Let me make sure you can see this. And we have the phaser board was just kind of hanging out here. There's a ton of dust. I'll zoom in so you can see this. You can see the dust and dirt here, and inside it looks all original. So the power supply has the original capacitors. This transistor seems to have been crudely replaced. I'll pick this up and show it to you. So we're going to take a look at that and see if that is a acceptable replacement transistor, and if there's any reason why we couldn't put it back to look like the other one under here. But we're going to recap the power supply and the entire keyboard. So all these little tantalum capacitors are going to be replaced. There's over 100 of them in this keyboard, but if none of them are short-circuited now, they would be pretty shortly after someone started using this keyboard. So we got to get rid of all the tantalum capacitors. And then another thing that we're going to do on this one, I may break it out into another video, is the voltage controlled filter, which is on the other side of this board. These are the pins that connect it. The voltage controlled filter is the 4075 filter, and we're going to do an enhancement on that that makes the keyboard sound a lot better. And of course we're going to get everything working, and then one final thing that we're going to do is we're going to MIDI this up. So I have an adapter that I've made that I'm going to put inside this that will let this keyboard be controlled by MIDI. So I'm going to start with recapping this, and I'll let you know if I see anything interesting along the way. Check out these sliders. I'm taking everything out of the keyboard. Those look really nasty. And some people would probably try to just squirt some contact cleaner in there and call it a day. But if you're going to keep your original sliders, the thing to do is to desolder them from the board and disassemble them and clean them completely. Polish up the metal with a Dremel, and with a wire brush on a Dremel, and then reassemble everything. It's very time consuming. It's more cost effective to buy replacement sliders, and I have replacement sliders, both original, not original, but reproduction of the original ones that look and feel the same as the originals. I sell a kit for most ARP synthesizers with all the sliders on my website, synthchaser.com. And then I also have the kits for the LED sliders. It's a little module that plugs right in there where your original sliders were. Same value and taper as all the original sliders, and they're just a lot more precise than the originals, and a lot better quality. So we're going to be putting the LED sliders in here, but I just wanted to show you what the original sliders look like. Here's a look at the one of the string control board, and you can see the white stuff. Some kind of liquid came in there. Actually got down here on the inside of the case. Some kind of liquid spilled into here at some point, but it's looking really gross. So here are the guts of the keyboard, all out, all the circuit boards, plus the random guitar pick that was inside. We have the power supply with all original capacitors, and this substitute transistor here that's been kind of oddly connected to the board. So I'm going to take a look at that and make sure that it's a suitable transistor replacement and that it's hooked up correctly. This is the upper voicing board. It has the master oscillator circuitry here, which makes a clock that the top octave generator chip then converts to the top notes of the top octave, and then it's divided down with these divider chips and then shaped into sawtooth waves with these resistors and capacitors, and clipped to negative side of it's clipped with this this band of diodes. And then this board is also responsible for gating the upper 29 notes of the board. There's one of these capacitors for each key on the board, on the keyboard. And if you have an ARP Omni with a note that's stuck on, and it's not a key contact issue, then most likely it's one of these capacitors having shorted. So we replace all the tantalum capacitors on the ARP keyboards. This is the string control board. I vacuumed up some of the dust off of that slider, but it still looks pretty gross. But they're going to come out, and the new LED ones are going to go in. This is the synthesizer control board, also very nasty looking sliders. This is the lower voicing board. It has the gating circuits for the lower 20 notes, plus for the bass notes have their own circuitry there. This is the synthesizer board. It has the controls for the synthesizer, LFO, amount, ADSR controls here. And then this is your voltage controlled filter. This is a 4075 submodule. This is the phaser board, which is responsible for the lush string sounds that this instrument can do. And this is the bass board, the bass voicing board or bass board. This is unique to the ARP Omni 2. The ARP Omni 1 doesn't have this. Basically, it's its own envelope generator and for the bass, synthesizer bass voices. And then it has your output jacks, and you have the different sections separated, and then a mix of all the voices together. So if you wanted to, you could just listen to the bass, send that output somewhere, or send the strings somewhere, the polysynth somewhere, or you can go through the mixer on the keyboard. So I'm going to start by, I always start with power supply, so I'm going to start by removing all the old components and taking a look at that transistor. So I took a look at this transistor to see if it was a suitable replacement for the one that should be there, and why there's wires kind of hacked on connecting it to the bottom here. So the way this thing works is there's a heat sink for these transistors. These are the past transistors for the power supply. And if you undo this screw, it disconnects the heat sink from the power supply circuit board, and you can pull it back, thereby disconnecting them from this socket. So here they used a replacement transistor that's a smaller package size than the one that was there. And as such, the little legs wouldn't fit into the socket. There doesn't seem to be anything wrong with the socket, just other than this is smaller and the legs don't fit in there. So they soldered these wires and connected it to the bottom. The smaller package size is a red flag that it's not going to have the same rating as the one that it was intended to replace. Plus, it looks cheesy, so my inclination would be to replace it. But nonetheless, I looked up this transistor, and the collector emitter, collector base, emitter base voltages, the rated current, they're all suitable as far as a replacement goes. But the power dissipation, the existing transistor is rated for 70 watts at 25 degrees Celsius, and the one here that that's replacing it is rated for 2 watts. So I have a replacement for the original one. This is an NTE 258. It's going to replace the MJE 1090 that was there. And you can see on the back it's a pretty solid piece, and it's got a nice connection for the heatsink. So we are going to replace this and remove this cheesy wiring, and I've already started to kind of cut off the tie wraps holding the capacitors down, and we'll remove those and replace them as well. So if my explanation of how this heatsink works wasn't clear, there's just this one screw here, and there's a nut underneath it, so I'm going to stick my hand underneath and just spin the nut off. And so you remove this screw, and unless someone's done something cheesy like solder some wires to the board, which I'm going to cut off here, you can then just slide this out. So if you ever need to change one of these transistors, it doesn't involve any soldering. You can just unscrew the heatsink, change the transistor, and then slide it back in. So now I'm going to change this transistor, and I'm going to apply some new thermal paste and a new insulator down there. And then I'll connect it when we're done recapping the power supply. So here's the completed power supply. So we've changed the polarized capacitors, these 3 big filter capacitors. We've changed from the original ones, which were manufactured in 1979, to these new ones, which are about the same size, but they're actually higher rated, higher voltage rating and higher temperature rating than the original. This is an 85 degree Celsius rated capacitor, and this one is 105 degrees Celsius capacitors. These are the best choice for power supplies, the higher temperature ratings, because they're going to withstand the abuse of the ripple current a lot better than these, and they're going to last much longer. I will also replace these tantalum capacitors, which may or may not have been short-circuited, and they're prone to short-circuiting, so we replace them all. And then we remove this underrated transistor and replaced it with a suitable replacement. The mica pad that's underneath there, I wound up using one of these, which is like a substitute for the thermal heatsink compound and the mica wafer. But basically, you need to make sure that that little heatsink on the back of the transistor is not connected to here, and therefore shorted to to chassis ground. So the old one, I wouldn't reuse this one, so I would always use a new one when I remount a transistor. So the power supply is kind of the heart of your keyboard. If you have a keyboard that hasn't had the power supply rebuilt or recapped, do it now, because if you don't do that, you're setting yourself up to have costly other repairs down the line. If something like this isn't something that you can do yourself, you can send your power supply to me. I have pretty much most synthesizers to rebuild it and test it in. So now we're going to move on to the other boards, basically pulling out close to 100 capacitors and all these sliders and replacing them. So I'll show you my progress. And one final thing I forgot to mention is I inspect the Molex connector and make sure that the contacts are clean. And when I was looking in this one, the ground connector is kind of bent down, and I don't think you're going to be able to see that in this video, but I'm going to take that out and replace that that crimped-on connector for the ground wire. Here on the bottom is the Molex connector that I removed. This was the ground connection inside the little wire harness here, and you can see that this is the replacement one. You can see that this goes to a greater height, I guess, if you're looking at this direction, like height. So the problem with this being bent down is it's not going to make contact with the header pin, and then you're not going to have a good solid ground for the instrument. So I replaced that, and I used a what's it called, trifurcon or whatever it's called, connector. So instead of just being flat on the top and only making contact in one place, this kind of hugs the header pin and makes contact in 3 places. So I use this for all my Molex cables. So now I'm onto the phaser board, and I'm recapping this board to change out the tantalum capacitors. And I count 4 tantalum capacitors, and my kit, the little handy list on my kit, says that there's 5. So I took a look around, and I see right here is the holes for the missing capacitor. And it looks like at some point someone broke that off. The leads are still connected on the back. That's the decoupling capacitor for one of the power rails. So strictly, I mean, it would probably still work without that, but it's there for a reason. It's a good practice, and we are going to put it back. So we're going to change those 4 that are there and add the missing one. So I got those tantalum capacitors off, and I noticed some rework done on the bottom of the board around here, as if something may have burned up when that capacitor here shorted or something like that. And I noticed some of the CMOS chips here and here have been replaced and socketed, and a couple of the delay line chips are in sockets that wouldn't have been put there by the factory. So when we get this installed again, I'm going to take a real close look at the phaser with the oscilloscope to make sure that there's no problems with it. Anytime that there's been rework done, it's a good opportunity to, I mean, it's a good practice to review that area, make sure it's working correctly and the rework was correct. I've pulled all the capacitors off the upper voicing board, and I've moved on to the lower voicing board. These are challenging to remove without lifting pads, so use very little heat, and might even consider just snipping the capacitors off first. So you need to use even less heat. So now I'm down here on the lower voicing board, and I noticed that one of the decoupling capacitors here had been snipped, so it's taken out of circuit. I'm guessing that this is probably shorted, or they suspected it was shorted, but we're going to remove it and replace all of these capacitors with electrolytics. So I've got the capacitors and the sliders off of this synthesizer board here. I'm going to leave the voltage controlled filter in place. I'm going to make another video where I do a sound test before and after the filter enhancement, just so you can kind of see what that does. The circuit board is like totally gross, and these sliders that came off are nasty. Some pubes fell out of one of them, and my hands got all greasy just touching the sliders when I took them off. But nonetheless, I'm going to save these because I'm actually going to, at some point when I'm bored and I have nothing to do, I'll have a stockpile of these original sliders that I've removed, and I'll go through and refurbish them and clean them up, and they'll be as good as new. Here's the pile of tantalum capacitors that I've taken off so far. So I've got 2 more boards to decap and remove the sliders from. Basically, anywhere where there was an opening on this synthesizer, just all manners of gross nastiness got inside of it. So I'm going to have to clean up these 3 circuit boards because I can't, in good conscience, leave it like this. Even if I were able to get solder to stick to the pads on the side where the capacitors are. But so I'm going to finish removing this stuff, and then we'll clean everything up and start putting things back together. So I was cleaning up the switches on this board. So this board, and this one I haven't gotten to yet. And I noticed a little blob of solder here on this chip. And that is mighty suspicious. So I turned it over and I had a look. And inspecting the solder joints here, I noticed that there's a cracked trace. I mean, not cracked, a cracked solder joint. So it looks like someone had touched up a couple of the pins of that and put the little blob of solder there. This is really cheesy, and I'm actually going to remove this chip and replace it. But it's always a good idea to just visually inspect all the boards. And you can find problems that you would have spent a long time chasing down once you reassembled things. So I replaced this chip, and while it looked very ugly, I tested it in my IC tester, and it actually is okay. But you can see the leads are damaged on them. So I just replaced it with a new chip. It's going to age a lot better than the original one anyway. So that cracked solder joint is repaired, and we can move on. So another thing that I found while inspecting the boards was over here, these 2 resistors are touching each other. The leads are touching each other and they're shorting each other out. So I'm not left-handed, so I'm going to hold the camera like this and just gently pull this up right like it should be. And there, potential short circuit avoided. Without burning any components up. So these boards, I've cleaned them up, but you remember the sliders were like a totally dusty mess. The boards were also really grimy, and they were actually greasy. And I think that someone at some point lubricated the sliders with some kind of oil-based lubricant like WD-40, and they just sprayed it in there like a putz, and it becomes a magnet to dust, and it totally gummed up those sliders, and it made a real mess of these circuit boards. Word of advice is don't go spraying things into your sliders unless you know what you're doing. So I got the old sliders off. I've also removed a couple of the other components here, like a resistor that here that goes between them, and these large ceramic capacitors. I'm going to replace them with smaller profile ceramic capacitors so my LED slider kit can fit in here. So I'm going to go and install the capacitors on this board and the sliders on all the boards now. So one thing I thought I would mention is here on the string control board. In my capacitor kit, I use the same values of capacitance as the originals, with the exception of this area right here. And when you desolder these, you'll see that there's 2 22 microfarad capacitors kind of crammed in here, and often like they're pushing on the resistors next to each other. I've seen them shorted out there before, just like the last one we saw where they were pushed together. So if you take a look at this, the 2 positive terminals of the capacitor are connected, and the 2 negative terminals of the capacitors are connected. So these capacitors are wired in parallel, and when you have parallel capacitances, they add up. So the 2 22 microfarad capacitors there are basically one 44 microfarad capacitor there, and they just did that because they had 22 microfarads on hand from elsewhere in the synthesizer, and didn't want to order a 47 microfarad just for this application. The capacitances have a huge tolerance, error tolerance in there. So they can be about, I think, plus or minus 20% of their specified capacitance, and the circuit will still work. So the 47 microfarad capacitor that I provide in the kit, out of convenience, to get this fitting in here without scrunching everything, is perfectly suitable to replace the 44 microfarads of capacitance that was there originally. So with the boards all recapped, the next thing I'm going to do is I'm going to install my LED slider kit. And if any of you have installed the Lumina upgrade in an Odyssey, this is much easier to do. Basically, you don't need to assemble anything. You just take the pre-built assembly and pop it in where your old sliders came out, solder it in, and then hook up the power to the LEDs, which is super simple. So I'm going to pop these assemblies in on the 3 circuit boards that had the sliders. There's the synthesizer board, synthesizer control board, and the string control board. So the next thing I'm going to do is the key bed. So you remove the key bed by removing 5 screws, 4 to 5 screws, hopefully, underneath the key bed on the bottom of the case. And then you'll be able to lift the key bed up and remove it. So I'm going to set it on the bench and we'll have a look. Just like anywhere else where there was any opening in the case, tons of dust. You can see under here, just these big dust bunnies. So we're going to take all the keys off and we're going to wash them. We're going to take all the key levers off and we're going to clean up this key bed really nicely. And I'm also going to clean the inside of this case. See all the dust there caught under the lip of the keys and the old heatsink compound and any other dust that came in on the jacks. I cleaned up the lubricant or whatever it was that was on the inside there by the sliders, and we'll get this nice and clean. Here I've got the keycaps coming off, the white and black keycaps coming off. You can see the difference in the color of the metal where it was covered up by the keycaps and where it was exposed for dust. And this is like a representative sample of some keys that I've taken off. So just wiping the top down without removing the keys is not going to get rid of that stuff, and it'll be visible, you know, when you play, and it's just pretty gross. So taking all the keys and putting them in my key washing bucket, and I'll fill it with warm soapy water and we'll get these soaking, and then tomorrow I'll scrub them off with my key cleaning brush, and then we'll let them dry while we do other stuff. So now I've removed the springs from behind the key levers and I've started removing the key levers. And I'm not doing this disassembling the key bed solely for cosmetic reasons. I mean, it is going to be nice to get that dust out of there and to wash the keys. But I'm doing it to get access to these key bushings, which are old and brittle and stiff and need to be replaced. And then also you can see that they're kind of uneven, and that's going to cause an unevenness with the keys. So I'm going to change the bushings and level the key bed, and then turn it over and clean the bus bar and the key contacts and adjust everything on the bottom side of that. And then this keyboard will be pretty much as good as new. So I cleaned the bus bar here, and I noticed that one of the key contacts had fallen off. This one right here. And I went to clean it up, and it turns out it was just a little fragment of the original key contact stuck somehow to this needle. So I'm going to replace this with a complete key contact and solder it in there to the part where it broke. Here's the new one soldered in. You can't really tell, except this one's just a tiny bit longer, but that's going to work a lot better than a sewing pin or needle. Here are the new bushings installed. Now I'm going to install the key levers and the springs. So this key bed was so dirty that I actually had to remove the circuit board here that holds the key contacts. I've removed the bus bars and cleaned them, so they're all nice and shiny now, and I'm working on the individual key contacts. You can see these are shiny and gold looking. These are kind of brown and grimy or oxidized looking. So I'm getting both the bar and the key contacts shiny and clean, so when they connect there's no crackling or notes that don't fire. One other thing I'm going to do before I put put the boards back in the synthesizer is this board. It was a real mess. You know, someone had sprayed something down, some kind of oil-based lubricant down into the sliders. It got all over the circuit board. It attracted dust and everything like that. These trimmers that are in here, they're like an open frame, so they're not sealed. So you know, invariably these are going to be gunked up as well. So I'm going to replace all 3 trimmers on this board because I'm pretty sure I'll have problems with them when I go to calibrate it. The trimmers themselves, you know, since they are not sealed, they do attract dust and junk in them just like your sliders do. And then they have this little bit of paint from the factory oftentimes, and then when you adjust it for the first time, the paint breaks off and gets inside there and causes problems. So I sell on my website replacement trimmers and a set of replacement trimmers for the entire synthesizer with the correct values and everything like that. Original, same manufacturer, drop-in replacement type thing. So I'm going to replace these 3 and then I'll be able to put the boards back in. And here those new trimmers are installed, and because of the same type of trimmer, we'll still be able to adjust it with a screwdriver through the little hole in the board once this is installed in the synth. So now we're at the point where we're ready to assemble everything back together, and if you've watched some of my other videos, you know that one thing that I always do first is I do a sanity check on the power supply. And get make sure that the voltages are present and that they're reasonably correct, and I kind of dial them in to what they should be. They'll go down a little bit when it's connected to a load, but we want to just make sure that this thing isn't going to damage anything when we put it in, since I've never seen this power supply run. And while I visually went over it, you know, I don't know if there's any bad components on there that wouldn't be normally part of the components that I'd replace. So I've got the mains wiring hooked up to the power supply. I haven't bolted the board down into the case in case I need to make any changes, and I'm going to fire it up. So I have here my meter measuring the plus 15 rail. I kind of took some old leads from a component and stuck them in the connector there. And my 15 volt rail is reading 15.14, which is fine. So I'm going to just dial it down to 15. So then when I connect it to the load, it shouldn't be putting out any more than 15 volts. And now I'm going to move the connector over to the minus 15, which is this one here. And here I'm reading at minus 14.94, so I'm going to adjust the negative rail trimmer here and just kind of bring that up to, or down to negative 15 on the nose. And again, you know, this is just kind of this isn't your final calibration for the voltages. It's just kind of to get things reasonably calibrated for when you connect it to the rest of the synthesizer. So since I have the power supply tested, now I'm going to put all the boards in, and we're going to test everything out and troubleshoot any remaining issues with the synthesizer. So now we've come to the part where it's time to fire this up. I have it partially open still, so if any smoke starts pouring out of it, I'll be able to see it quicker. Yeah, we're going to see if we have more issues to resolve, or if what we've done kind of has brought this thing back to life. So turn it on and let's try out the high strings. It's working. Let's try the low string bass. The other string bass is working. Let's try some of the, like the chorus phaser is working. The hollow waveform is working. Let's try attack and release. It works. Release. It works. So string section is actually looking pretty good. Let's check out the synth section. And I have just a very basic patch on here. Frequency all the way up and sustain all the way up and everything else down. And this is the sound that I would expect to hear. So let's try the other synth voice. Is working. Synth bass is working. Working. Staccato is working. I'll fiddle around with the filter a little, and this hasn't been calibrated, and I've changed out the filter, the trimmers that affect the filter. So it hasn't been calibrated and the filter hasn't been enhanced yet, but let's just see if these parameters kind of change the sound. Let's see if the LFO is working. It is. Let's attack. Let's try some filter release. It's working. So it actually looks, I'll go through this again off camera, but it actually looks like everything is working. We have to calibrate it still. We have to do the filter enhancement, which is going to be done in a separate video. I'm going to hook the power to the LED sliders, and then I'm going to MIDI this keyboard up. But it looks like it's alive and working well. So maybe when I calibrate, I'll find something else, but I'm going to go ahead and do the calibrations now, and we'll see. I think I'm going to make a separate video on how to calibrate the ARP Omni 2 in case anyone watching owns one and is interested to know how to tweak these trimmers inside properly to get everything calibrated. And then one other thing I want to mention is that this kind of shows that a systematic approach is really necessary or ideal for restoring these. I mean, going through each board and doing the things that you know that need to be done, changing the capacitors, cleaning or replacing the trimmers, cleaning the key contacts, and then going over everything with a fine-tooth comb is really what it takes to make these keyboards dependable. I mean, if I had just gone in and found the one shorted tantalum capacitor or something, whatever it was, that was preventing this keyboard from working when I got it, yeah, it would have worked, but it wouldn't have been a dependable instrument. And it's kind of labor intensive to do this to these, but you do it once and then it's going to be solid and reliable for a long time to come. So now we've got the filter enhancement made, and if you haven't watched it, there's another video that you can watch to see about that. And I've hooked up the power to the LED sliders. Typical Omni sound there. You can add resonance to it. And you can get creative with the sounds, particularly now that the filter enhancement is. And with that, the ARP Omni 2 is finished. So, John, I hope you enjoy your ARP Omni 2. And for those of you watching, hopefully this gives you an idea of what goes into the restoration and repair of these ARP Omnis. It's just a very labor-intensive process to methodically go through everything and make the instrument dependable and reliable and sounding good. So if you have any questions about ARP Omnis or ARP Omni 2s and repair or anything about them, just feel free to post in the comments or send me a message through my website, synthchaser.com. I also have a lot of the products that I used on this keyboard, like the LED sliders and the key bushings and the capacitor kits. So again, thanks for watching, and have a great evening.